In this lesson, we're going to learn about the volume of pyramids and cones. So the first thing we need to look at is what important informations or dimensions you need to know from a pyramid or a cone. So the volume is 1/3 the product of the base, the area of the base, and the height of the figure. So that formula is given to you right here. But when we look at this, we have to know that height is always measured perpendicular to the base. So this next idea here is the altitude or the height of a pyramid or a cone is the perpendicular distance between the vertex and the base, versus you might see a situation where you have a slant height. And that's going to require you to then find the height. So the slant height is just as it sounds, it's slanted. So this right here would be the slant height in both. And then the height or the altitude of the cone or pyramid goes from the vertex and it's perpendicular to that base. So remember, slant height is not perpendicular to the base. It's actually, the slant height is actually the height, if you look in this pyramid, it's the height of this triangle. So it's not the height of the pyramid though. But you can see that there's this little right triangle formed in both of these pictures. And since we have a right triangle, we have a hypotenuse, we have a height, we'll be able to find the slant height if we need it, or we could find the height if we're given the slant height to plug into our volume formula. So they kind of are going to go hand in hand. So just notice that you have these right triangles formed. So looking at this first example, we want to find the volume of this regular pyramid. So that means it's a square pyramid. That means the base is a square. And we want to round our answer to the nearest hundred. So the first thing is I'm going to write down my formula. So 1/3 capital B times H. Remember, I'm going to write it up top here too. The capital B, just like for prism, stands for the area of the base. It's not a dimension of the base, it's the area of it. So that means area of the base. So when I look at this, my base is a square. So to find the area of that square, well, that's no problem. It's just going to be length times width. So that's just going to be 7 times 7. But then in order to find the height, well, remember the height is that perpendicular distance to the base. And what they give me here is the slant height. That 11.5 represents the slant height. So when you look, you hopefully are seeing that you have this right triangle formed with the slant height, this distance here, and the height. Now this distance on the bottom will always be half of this edge, because the height will always go through the center of that base. So that means that this right here is really going to be 3.5. So this ends up being, before I can actually find the volume, I have to find the height. So off to the side here, I'm going to find the height to plug in. And I'm going to use my right triangle that's highlighted there. So H 3.5 and 11.5 centimeters. So again, this is that blue triangle that I highlighted in the picture. So I'm going to be using Pythagorean theorem for this because I have a right triangle. SOHCAHTOA could come back into play here if you have a right triangle, so just keep that in mind. So I'm going to have 3.5 squared plus h squared equals 11.5 squared. So 3.5 squared gives me 12.25 plus h squared. 11.5 squared gives me 132.25. So subtract that 12.25 from both sides. So we end up with h squared equals 120. And then I'm going to go ahead and just square root. So I get h equals the square root of 120. Now, if we can break this down, that would probably be beneficial just so it's a little bit easier. If you left it as a square root of 120, though, that would be okay. I wouldn't write it as a decimal, though, because then when you're dealing with, your equation, when you go to plug back in, you're going to have to put in all those decimal places because remember, we don't want to round till the end. So I would recommend just leaving it as the square root of 120, or if you want to break it down into simplest radical form, just to review that with you, I could divide this by 4. So square root of 4 times 30. So this would be 2 root 30. That would work. So that's going to be your height. So then if I take this or the square root of 120 and plug it back in, my volume, so I'm going to go ahead and type all of that in. So 1/3 times 7 times 7 times 2 root 30. That's going to be 178.92. And it says to the nearest hundredth. So I'm just going to write the decimal and then I'm going to round after. So 9227, rounding to the nearest hundredth means 2 decimal places. So it's going to be 0.92. I'm going to switch this to say approximately equal since I'm rounding. My units, it's centimeters cubed or cubic centimeters since we're talking about a volume. So this was really step 1. Here was step 2. So that's kind of as complicated as it could get with just finding a volume, because in that case you had to find height. So be careful. Make sure you don't just start plugging in the numbers you see. Make sure you think about, what do these numbers represent? Is this the slant height? Is this the height? The formula always requires you to know the height, the perpendicular distance from the vertex to the base. So let's look at one more example. This one's a cone, so without a picture. So I'm just going to draw in a picture. So we have a cone. The altitude of this cone, so in this case, this is the height, so that's the perpendicular distance here. That's 25 centimeters. And it tells us that the volume of this cone is 675 pi cubic centimeters. We want to find the radius. So again, if we think about our formula, 1/3 area of base times the height. Well, the cone's similar to the cylinder in the sense that the base will always be the same. So I'm going to go up top for a second and I'm just going to write that in. So volume for a cone, if you think about it, it's 1/3 area of the base times the height. Well, the base will always be a circle similar to the cylinder. So it's really always going to be 1/3 pi r squared times h, because this area represents the circular base, and that'll always work for a cone. So for cones, you can always just use this formula here. And then for pyramids, though, you're always going to have to use capital B times H, because you don't know what that, or 1/3 capital B times H, you don't know what that base is going to be, what shape it's going to be. So you just have to be mindful of that, because that's going to change what you do. So going back to this example, I have, so instead of writing this formula, I would just write 1/3 pi r squared times H. And then we plug in what we know. Well, we know the volume is 675 pi. 1/3 pi r squared, I don't know r, and I know that the height is 25. So right away, I'm saying let's get rid of these pi's. Let's divide both sides by pi, right? So those are gone. And you don't really have to show the dividing by pi, you could just cancel them. So then I have 675 equals 1/3 r squared times 25. So at this stage, what I would do is I would combine these. So you have 675 equals 25 over 3 times r squared, because remember that's over 1. So 25 times 1, 3 times 1. And then you can either divide both sides by the 25 over 3. Remember from algebra, you can multiply both sides by 3 to cancel those. So if I'm just reviewing that algebra skill with you, you could just divide both sides by the 25 over 3. That's fine too, but I just want to review the algebra with you. So if I multiply both sides by 3 to clear that denominator, I get 2025 equals 25 r squared. Divide that number by 25, you end up with 81. equals r squared. Square root it. So you get 9. So that means that your radius for this example is going to be 9 centimeters. Again, notice I just have centimeters, not cubic, because I'm just talking about a dimension here or a length, not a volume. So those are some different types of examples, just again using the formula. So remember, volume formula will always be the 1/3 pi r squared times h for cones. But for pyramids, it's going to be this generic with a capital B representing the area of the base, because the bases will change for pyramids. Keep in mind the difference between heights versus slant heights, and get some key ideas written down, and go ahead and try some of those check your understanding problems. We'll talk about those in class tomorrow.